Hello, it's Mrs. Green, and the second part of our Pythagorean lesson is on the converse to the Pythagorean theorem. So here we have Pythagoras and some converse. So you can imagine him wearing Converse All-Stars, if it helps you remember. Converse usually means in geometry the opposite. So it's saying the same thing. We're still saying the Pythagorean theorem, but we're saying it kind of in a reverse way. So you need your prior knowledge. And then we're going to jump to the key information. So the converse of the Pythagorean theorem states that if the sides of a triangle, so you don't know if the triangle is a right triangle, you just have a picture of some random triangle, and notice in my red triangle I didn't put the little symbol for right triangle, so we don't know if it's a right triangle, and the sides are ABC like we're getting used to. If those side lengths, so they give you the side lengths, so let's say they give you 5 and 12 and 13. If those numbers turn out to work so that a squared plus b squared equals c squared, then the triangle's a right triangle. So the converse, so in the Pythagorean theorem, we're saying that if we know two of the side lengths, we can calculate the third by using the Pythagorean theorem. In the converse, we're checking to see if the triangle's a right triangle. In the original Pythagorean theorem, we're given that it's a right triangle. Your picture is going to have the right triangle symbol. And once you see that, you know that you can use the Pythagorean theorem because it's a right triangle. You can go right to the Pythagorean theorem and calculate the unknown missing side. The converse, however, is doing the opposite. You're given three sides and you want to see, is it a right triangle? Does it deserve the little indicator? And the way you check that is you plug in the numbers into the formula. If it works, if it balances, if everything's good on both sides, the numbers are equal, then you can say, yes, it is a right triangle. So that's the way it works. It's backwards. So let's do some examples. Okay, so we have example 1A and 1B, and the instruction set, or the question is asked: is the triangle with sides of the given lengths a right triangle? So there's no picture here. If there were a picture, I could draw a little mini picture. I'm not going to indicate that that's a right triangle because I do not know until I do the calculation. So that would be 4, 5, and 7. And they've given me the lengths. And so I'm going to use the Pythagorean theorem converse to see. So I'm going to fill in A, B, and C. I'm not calculating an unknown side like I was with the Pythagorean theorem. I am checking to make sure, to see if this triangle, if I were to draw it, would I want to indicate that that was a right angle. And I have to be careful because I know that my largest side is my hypotenuse. So when I'm plugging these numbers in, the thing that you just have to watch out for is that you put the biggest number as C. The A and B don't matter. It doesn't matter which leg is which. They're both legs. So I'm going to substitute 4 for A. So that's going to be 4 squared, and 5 for B, 5 squared, and 7 for C, 7 squared. Now I'm simplifying to see if this equation, once I simplify, is balanced. So I'm going to get 16 plus 25 equals 49. And when I add 16 and 25, I get 41. And we know that 41 is not equal to 49, so this is not a right triangle. Not a right triangle. All right, let's do example B. So again, I'm going to use a squared plus b squared equals c squared to test. I'm going to substitute 5 and 12, the two smaller sides for A and B, and the larger side for C. So that gives me 5 squared plus 12 squared equals 13 squared. Let's fix that. 13 squared. And if you know your Pythagorean triples, this is going to work, I'm sure. But we'll just prove it by simplifying. That's 25 plus 144 equals 169. So that's 961, yay. So since it is balanced on both sides, the answer here would be yes, it is a right triangle. So when I draw this triangle, I can indicate that it's a right triangle with the indicator. I don't know the name for that symbol. I guess it's just a right triangle symbol. Okay, you're going to have similar problems as your practice. All right, we've got 4 practice problems. Same instructions. Is the triangle with sides of the given lengths a right triangle? So you've been given the 3 lengths. You're going to fill in the Pythagorean theorem with the 3 lengths, being careful which number you use for A, B, and C. And then simplify, see if the equation stays in balance. If not, then no, it's not a right triangle. If it does, yes, it is. So there are your 4 problems. And then at the end, you're going to do your wrap-up summary. That's part of the notes where you are more engaged. Hopefully you're engaged during the whole lesson, but if you're in the habit of kind of just going through the motions and copying stuff, the summary and the prior knowledge will force you, motivate you to engage even more. All right, I'm signing off.